Hello, good evening students. Let's try to understand chemical properties of phenol student that we are supposed to study student. So there are some reactions are there in the phenol student that we have to look over it. So student, if you talk about the first reaction, it is treated with chloroform and NaOH and then it is hydrolysis student. So this reagent is chloroform and sodium hydroxide. This reaction is Reamer-Tiemann reaction student. If I will write here, this is the Reamer-Tiemann reaction student. This is named reaction Reamer-Tiemann reaction. And what it is the product it is going, I am writing in the single step student, but this reaction is given by the in multiple steps. So it will give the salicylaldehyde student. So here you will find that is this will be the OH group and here is CHO group student. And if you write the name student, this name will be salicylaldehyde. Right student, SALICYL dehyde, ALDEHYDE. This is the salicylaldehyde student. Now here if you are talking about NaOH and CO2 student, this reaction is called Kolbe reaction student. This is the Kolbe reaction, KOLBEY, Kolbe reaction. So if you talk about Kolbe reaction, it is also the two step. Firstly it will form the sodium phenoxide, then it will give the salicylic acid student. So here we are writing the product student, salicylic acid. So here you will find the OH group student and here is COOH group is going to be the added student. So this will be the salicylic acid. Salicylic acid. Now next one is there student, this is the oxidation student, sodium dichromate on acidification it will give the quinoline student. This reaction is called oxidation of phenol student. So what the product you are going to obtain in this reaction student, this is the double bond O. In the center there is no the alternate bond are not there student, it is the two bonds are there, double bond in the ring. This is what the compound is called student, benzoquinone. So here I am writing this is the benzoquinone. Now student, next one, here is zinc student. This reaction is called the reduction. When phenol is treated with the zinc dust student, this gives the benzene student. Okay, so this is what the product you are going to get student, benzene. Next one is student, if you are treating the phenol with the bromine, with bromine in carbon disulfide student, it is the non-polar solvent. So it will give monosubstituted student, monosubstituted bromophenol student. So OH will be here student and Br will be here. Okay, this is the major product student, this will be the major product. Here you will see OH group is as it is, here can be Br. This is the minor product student, orthobromophenol and parabromophenol. But if you are treating with the water student, it will give the tri-substituted phenol student. So here is the OH student, this is going to be Br, this is again Br student and this is Br. Right student, firstly you student, now see the dilute HNO3. If you are treating with the dilute HNO3 student, it is also going to give the monosubstituted student. It is going to give monosubstituted nitrophenol. So it is OH student and here it will go the NO2 student. Now if you are treating with the concentrated HNO3, it will give the trinitrophenol student. Okay, tri-substituted. So it is the OH here student. This place it is going to be NO2. Then 2,4,6 trinitrophenol is the our product with the concentrated nitric acid. If you are treating with the sodium metal student, it is going to give the sodium phenoxide here student. It will be the ONA plus half molecule of hydrogen gas will liberate. Here NaOH also it is neutralization reaction student. So it will give again ONA plus it will give student H2O. One more reaction is there student, one more reaction, and that reaction is called coupling reaction. This reaction is called coupling reaction. And how you are going to treat this student, this one is diazonium chloride is there. You are treating with the diazonium chloride. This reaction is called student coupling reaction, right? So let us see the coupling reaction in little bit detail student. Here we are having the phenol student. This is, here is the OH group are there as it is, and here is the hydrogen. Now this is the Cl, here is the N2 student, and here is the diazonium chloride as it is. What will happen? This bond is going to be minus HCl student. This is the minus HCl. So let us try to see the product student. This is the OH group, here is the, here is N double bond, this is N, this is the product. So it is called student para hydroxyazobenzene, para hydroxyazobenzene. So student, if you can see, count the reaction, there are many reactions are there that you can note out. 1, here is the 2, this is the 3, here is the 4, this is the 5, 6, 7, 8, 9, 10 and 11. Total 11 structures are there student, 11 chemical properties. So firstly, phenol, if you are treating with the chloroform sodium hydroxide, it will give salicylaldehyde. The reaction is known as Remer-Tiemann reaction. Secondly student, if you are treating with the, what the reagent, if I will tell student, if you are treating with the NaOH and carbon dioxide, it will give salicylic acid. The reaction is called Kolbe reaction. On oxidation with sodium dichromate student, it will give benzoquinone. On reduction with zinc metal, it will give benzene student. If you are treating with bromine in CS2, that is called the para-bromophenol student. Bromine water student, 2,4,6 tribromophenol. Dilute HNO3 you are taking student, orthonitrophenol. Concentrated nitric acid, 2,4,6 tribromophenol. Sodium metal, sodium phenoxide, NaOH sodium phenoxide. With the diazonium chloride, it will give para hydroxyazobenzene student. So this is all about the answer student. Thank you very much for watching students. If you find this video helpful, please do like and subscribe the channel student. Thank you very much for watching.